this lesson is going to discuss derivatives of transcendental functions. And so if you remember from algebra, transcendental functions are the functions that actually transcend algebra. They're above algebra. So these are trig functions, logarithmic functions, exponential functions, things like that. Things that don't follow the typical algebraic rules. So when we look at the derivatives of these functions, we're going to kind of just focus on trig functions for this first video. And if you remember what the sine function looks like, we have it here in red. And if you take a look at, again, remembering the derivative is the slope of the function, if you look, for instance, at 0, and you kind of draw that line in there, you can see that you have a slope of about 1. And then if you kind of move over here to pi over 2 or 1/2 pi, then you can see that it's leveled out there, so our slope is 0. Kind of moving a little bit further onto pi, you can see you have a slope of -1. A little bit further, 3 pi over 2 or 3/2 pi, you have a slope of 0 again, and then finally at 2 pi you're back to that slope of 1. So if you plot those points, you can see how they're falling on the blue curve, which is cosine. So that's how we know that the derivative of sine is cosine. We could do something similar for cosine to find that the derivative of cosine is actually negative sine, and it gets shifted by 180 degrees or pi. So our derivative of sine, like we said, is cosine, and our derivative of cosine is negative sine. Keep in mind that we may need to use the chain rule if we don't have x. If we have something like 5x or x squared or something like that, we'll need to take the derivative of the inside as well. So let's take a look at a few examples. The derivative of 2 sine x, again, coefficients just come along for the ride, so that's just going to be a 2 out front. Derivative of sine, we said, is cosine, so this is just 2 times the cosine of x. For the second one, we got the 7x on the inside, so y prime is going to be, derivative of cosine is negative sine. Leave the 7x alone, we don't touch it, and then we take the derivative of 7x, which is just 7, and then we're going to move that to the front. So we've got -7 times the sine of 7x. So at this point I want you to pause the video, try example C, and enter your answer in the online system for this lesson assignment. And then resume the video and we'll look at example D, which has an x cubed on the inside. So we've got y prime is 2, again, derivative of sine is cosine. And then we've got x cubed is just going to stay as is. Again, we're not going to touch it until we do the chain rule, which gives us a derivative 3x squared. Again, we're going to move that to the front so that we don't get it confused with the angle inside. 2 times 3x is 6x squared, and then we have cosine of x cubed. 2 more examples here. We've got sine of 1 minus x. Our derivative is going to be, derivative of sine, we said, is cosine. 1 minus x is going to stay as is, and then we'll do the derivative of the 1 minus x. So let's be careful here, because the derivative of negative x is -1. Again, moving that to the front, we have our derivative is negative cosine of 1 minus x if we move that -1 to the front. And then our final example here, we've got y prime is going to be 3 is just going to again come along for the ride. Derivative of sine is cosine. Leave the inside alone. And then we take the derivative of the inside, so x squared plus 4, derivative of that is just 2x. Last step, we're going to move that 2x to the front, so we end up with 6x times cosine of x squared plus 4. So this is going to conclude the first video for this lesson, just that introduction to the derivative of sine and cosine. The next video is going to look at some examples using the product and quotient rule for these two functions.